As promised, here is your quadratic equations quiz review. So we'll start by looking at a quadratic equation in vertex form. The easiest thing to find here is our vertex, which is at -1, 4 is my vertex, and my axis of symmetry then is x equals -1. Now, since my leading coefficient is negative, I know that the parabola opens down, making the vertex point a maximum, which means my range is y is less than or equal to 4. And finally, we can find the differences fairly easily, again by looking at that leading coefficient. So I've got my first differences, and my first difference is equal to that leading coefficient, so -2. My second difference is always going to be twice that leading coefficient, so -4. And I just add -4 every time to get my next first difference, so -2, -6, -10, -14, and so on. The last few things I'm going to want to do here, I'm going to want to convert the vertex form equation to standard form. I think I also want to take a quick look at graphing this. Okay, so converting to standard form. First step, I write out what the squared means, that I'm multiplying x plus 1 times x plus 1. I FOIL it out. Next, I distribute the leading coefficient through all of this right here. And finally, I combine the like terms to get my y-intercept of 2. So my final answer for putting this in standard form is right down here. And that reminds me, I forgot to talk about how we get the y-intercept when we're just in vertex form without converting to standard form first. And to do that, we just put a 0 in for x, so we would end up for my y-intercept with, let's see, y equals -2 times 1 squared plus 4 is y equals 2, giving me my y-intercept of 0, 2, which is exactly the same thing my standard form equation should be telling me right down here. The final thing I wanted to look at is graphing. So you can see on the set of axes at the right, I went ahead and put my vertex right here at -1, 4. And I also recall that my y-intercept was 0, 2, meaning if I go 1 unit to the right, down 2, 1 unit to the left also takes me down 2 by properties of symmetry. So I should have my parabola looking something like this. And I could make my graph even more accurate, and you can certainly on graph paper, but I can make a table of values x, y, and I can start at the vertex at -1, 4. I know I had 0, 2. I also know that I should have -2, 2. And I should also have 1, -4, meaning that I will have -3, -4. So a table of values can help you make an even more accurate graph. Now we're going to take a look at a quadratic equation in standard form. So let's look at the quadratic equation y equals 3x squared minus 9x plus 6. It's really straightforward to find my y-intercept. It's just 6, so I've got 0, 6 as my y-intercept. It's also pretty easy to find the range then. I know this opens up because of... Oh, I'm sorry, I've skipped ahead of myself. I need to find my vertex first. So to find my axis of symmetry, the x-coordinate of my vertex, I'm going to do x equals -b over 2a, which is going to be -9 over 2 times 3, which is 3/2. And I can take that and plug it back in to find the y-coordinate of my vertex. So here I've plugged it in everywhere, and then I do my calculations. Okay, y equals 3 times 9/4 minus, that'll be 27/2 plus 6. So y equals 27/4 minus 27/2 plus 6. Y equals -27/4 plus 24. fourths, which is going to be negative 3/4. Okay, so my vertex then will be 3/2, negative 3/4. And now it will be easy to say that since this opens up, my range is y is greater than or equal to negative 3/4. And just cleared myself a little bit of space there because now I'd like to talk about differences. I've got my first differences. Let's see, well, the leading coefficient is 3, so my first difference is 3. I know my second differences are twice that leading coefficient, so 6, which tells me that my next first difference is 3 plus 6 is 9, plus 6 again is 15, and on and on. Remember, I do need at least 3 first differences when I ask for them on your quiz. Now I can also write the standard form equation in a different form. I do, since I have the vertex here, have all the information I need to write this in vertex form, so I'd have y equals 3 times x minus 3/2 squared minus 3/4, remembering that the leading coefficient is the same in both places. That's where that 3 is coming from. So there is my vertex form equation. Now I've also picked the numbers so they work out fairly nicely here, so I can do a standard form equation. I'm sorry, I meant to say fairly easy factored form equation. So first I notice a 3 in common in all of my coefficients. So I can start by factoring that out and saying y equals 3 times x squared minus 3x plus 2. And I can factor x squared minus 3x plus 2. So y equals 3 times x minus 1 squared, oops, not squared, x minus 1 times x minus 2. And again, that is because negative 1 and negative 2 multiply to give me 2 and add to give me negative 3. And this tells me that my x-intercepts are 1 over 2 for my x-intercepts there. And I'm not going to draw the graph, but it would be fairly easy to do. We know several points. We know the point 0, 6. We know the vertex at 3/2, negative 3/4. I know my x-intercepts, so that's 1, 0, and 2, 0 are both points. And I could plot a table of values as well if I wanted to. And finally, I'm going to look at a factored form equation. So here's a factored form equation, and the nice thing about a factored form equation is how easy it is to get x-intercepts, which in this case are negative 2, 0, and 3, 0. So I've got 2 points right there. Now, some of you were wondering, how do I find, then, the equation of the axis of symmetry? Well, notice that these x-intercepts both have the same height. My axis of symmetry, then, is halfway in between. So to find my axis of symmetry, I can say negative 2 plus 3 divided by 2 is 1/2, so x equals 1/2 is my axis of symmetry. And I can plug that the positive 1/2 back into my equation for my x and solve for y to find the coordinates of my vertex, just like I did in standard form. So I know that y equals 1/3 times 1/2 plus 2 times 1/2 minus 3, so y equals 1/3 times 5/2 times negative 5/2, which is going to be negative 25/12. That's a pretty number. So my vertex is 1/2 negative 25/12. Alright, so I've written my vertex up at the top of the screen here so I can erase and give myself some more room to work. Okay, now I know the coordinates of my vertex. Leading coefficient is 1/3, so I know this opens up. So my range is y is greater than or equal to negative 25/12. Let's see, I can also find my y-intercept by plugging 0 in for x, so I end up with y equals 1/3 times 2 times negative 3 is going to be negative 2 for my y-intercept. So I've got 0, negative 2. I think again I'm going to take a look at first and second differences. I know my leading coefficient, so my first difference is equal to that leading coefficient, which is 1/3. My second differences are double that leading coefficient, so 2/3, and I'll add that every time to get my next first difference. So 3/3, or 1, I'll have 5/3, and that goes on. Remember that I need at least 3 first differences. And finally, we will convert to other forms. Again, I've found the vertex, so vertex form is fairly easy. Y equals 1/3 times x minus 1/2 squared minus 25/12. Again, remembering the leading coefficients are always the same, so that's where the 1/3 comes from. And that is my vertex form. And finally, to get standard form, I'm going to FOIL out my factored form. So I'll get 1/3 times, that'll be x squared plus 2x minus 3x minus 6, which will be y equals 1/3 times x squared minus x minus 6, which will be y equals 1/3 x squared minus 1/3 x minus 2. There is my standard form. Now the final thing I'd like to remind you about is just these properties of symmetry. So I know if I have point 5, negative 7 and 18, negative 7 on the graph, I know my axis of symmetry is halfway between, since they are at the same height. So my axis of symmetry will be x equals the average of the x-coordinates, 5 plus 18 divided by 2, so x equals 23/2, or x equals 11.5 would be the equation for my axis of symmetry. Now I also know if I have the axis of symmetry in a point on the parabola, I can find one more point. So if, for example, my axis of symmetry is at 3 and I've got a point negative 1, 7, well, this is 4 units to the left of the axis of symmetry, so I'll have another point at the same height 4 units to the right, which would give me a point 7, as another point on my parabola. That should be a fairly comprehensive review of everything that will be on your quiz, and let me know what questions you have on Monday.